Cramer's rule, using determinants to find the values of three variables. We must first find the A matrix, which is just taking the coefficients. So -1, 4, and 1. Then the y's, 1, -1, 2. The z's, 1, 4, -1. Now to do these, remember if you have that, copy these first two columns, -1, 4, 1, 1, -1, 2. And then we go diagonally like that, multiplying out. 3 -1s is -1. 1 times 4 times 1 is 4 plus 4. 1 times 4 times 2 is 8. Subtract. Don't forget to subtract. Now going up. 1 is -1. 2, 4 is -8. And -4. This becomes an 11 minus a -13, which becomes a 24. So the A is 24. That is going to be used to help us find the X and Y's or Z's as we go forward. Now, to go get X, we stick these constants in place of these coefficients, then we leave the Y and Z's in there. So here we go, it's -3, -14, and 9. Then it is, now the Y's, we go 1, -1, 2, 1, 4, and -1. Then we repeat the first two, -3, -14, 9, then 1, -1, and 2. Again, going down diagonals. Here we go, negatives. It's going to be a -3, 36, and a -28. Subtract. Now going up. -9. That's 8. It's -24. And +14. So we have, let's see, 8 is 5, I guess. Minus, this is 10. -10. And -9 is -19. Add that up, you get 24. So the X became 24, but you divide by this, so 24 divided by 24 equals 1. So X equals 1. All right, let's go try to find the Y, I guess. So I'm going to take, put these constants in for the Y's now. So here's the X's first. I have -1, 4, and 1. Now that the Y's, -3, -14, 9. The Z's, 1, 4, and -1. I repeat the columns, the first two columns, -14 and 9. Diagonals. So I have a -14, I have a -12, and a +36. Again, I subtract going up now, 2 and 3. I have a -14, -36, and a +12. Let's see, this is -26. This is a +10 minus. This is -24, 38, -38. Add these up. It's positive. This becomes 48. Again, we're doing the Y. You divide by the A. So 40 divided by 24 equals 2. So Y equals 2, X equals 1. To find Z, you just plug the two variables in here. So I have a -X, which is the 1 down here, positive Y, which is 2, and find the Z. So I'll do that real quick for you over here on the side. Again, it's -X, so it was a +1 earlier, so it's -1. Y is just the plain old 2 we found to be 2. Right, we're trying to find Z equals -3. So this becomes a 1 plus Z equals -3. Subtract 1, Z equals -4. So there's your Z. We found our Y. Here's your X. Answer is 1, 2, -4. Quick review of the quadratic graphing. Standard form for this one, using the equation x equals -b/2a. So So it's negative 8 over 2 times 4, negative 8 over 8 equals 1. Actually, negative 1. So at negative 1, axis of symmetry is all along here. Find the y value, stick negative 1 back into the equation. So negative 1 squared is 1, times 4 is 4. Negative 1 times 8 is negative 8, plus 1, that'll be a negative 3. 1, 2, 3. There's my vertex. This point will give me my y-axis intercept. That's right here. I mirror across. My next point's going to be way up off the graph, so we're done. We'll just kind of draw that the best we can. Moving on. Vertex form, intercept form. Change the signs of positive 1, positive 5 are your x-axis intercepts. Midway between them is just 3 will be your axis of symmetry. To find that vertex, put that value for x, which is 3, back into here. So 3 minus 1 is 2. 3 minus 5 is negative 2. That's negative 4. 1, 2, 3, 4. I need to find this point here to mirror to this side. This is 1, 2. X is 2. So 2 minus 1 is 1. And 2 minus negative 5 is negative 3. Times 1 is negative 3. 1, 2, 3. Mirror across. That is now complete. Last one I have is vertex form. Change that sign. It's 3, 2 for the vertex. 1, 2, 3, 1, 2. Axis of symmetry is there. Now I just got to plug values in. I'm going to plug 2 in here. That'll mirror across to this side. 2 minus 3 is negative 1. Squared is 1. 1 plus 2 is 3. 1, 2, 3. I'll try 1 into this. 1 minus 3 is negative 2. Negative 2 squared is 4. 4 plus 2 is 6. 1, 2, 3, 4, 5, 6. Mirror across. There's your graph. Good luck.